124 light-years away, there's a planet that scientists have called one of the most promising places in the entire galaxy to find life beyond Earth. It's bigger than Earth. It might have a global ocean, and its atmosphere contains chemical signatures that, for a brief moment in 2023, made headlines around the world for a very simple reason. Some of those chemicals, on Earth, are only produced by living things. So, a team of astronomers did something almost nobody has the resources to do. They pointed two of the most powerful radio telescopes on the planet at this exact world for over a month, and they listened. What they found, and what they didn't find, tells us something surprising about how close we might actually be to answering the biggest question humans have ever asked. This is K218b. K218b orbits a small, cool red dwarf star in the constellation Leo, about 124 light-years from Earth. That sounds unimaginably far, and it is, but in cosmic terms, it's practically a next-door neighbor. The planet itself is what astronomers call a sub-Neptune, bigger than Earth, smaller than Neptune, a size category we don't actually have an example of in our own solar system. For a long time, that made it hard to know what these worlds even look like up close. Then the James Webb Space Telescope pointed its instruments at K218b's atmosphere. And what it found was strange enough to change the conversation entirely. Webb detected both carbon dioxide and methane in K2-18b's atmosphere, but almost no ammonia. That specific combination matters because it's consistent with a particular kind of world scientists call a Hycean planet, a hydrogen-rich atmosphere sitting on top of what could be a deep global liquid ocean. An ocean world orbiting in the habitable zone of its star, with an atmosphere that behaves the way scientists predicted an ocean world's atmosphere should behave. That alone would have been enough to make K2-18b famous. But there was one more detail buried in the data that turned this into one of the most talked about exoplanets in modern astronomy. Some analyses of the atmosphere pointed to a possible signature of a molecule called dimethyl sulfide. On Earth, a gas produced almost exclusively by marine life, largely phytoplankton in the ocean. To be clear, this detection has been debated, reanalyzed, and is far from confirmed. Science doesn't move in straight lines, and plenty of researchers have pushed back on how confident we should be in that specific signal. But the possibility alone was enough to make K2-18 be one of the single most important targets in the search for life beyond Earth. And that made it the perfect candidate for a very different kind of search, one that doesn't look at chemistry at all. If K2-18b's ocean has microbial life, we'd never hear it. Life doesn't broadcast radio waves, technology does. So, a research team decided to ask a completely different question. Not, is there life on this planet, but is there a civilization on this planet advanced enough to build a radio transmitter? It's the same basic idea behind SETI, the search for extraterrestrial intelligence, but pointed at one specific, carefully chosen target instead of scanning the sky at random. To pull it off, they needed serious hardware. The team used two of the most powerful radio observatories on Earth: the Very Large Array in New Mexico and the MeerKAT Array in South Africa. Having both of these instruments coordinate on the same target across multiple observing sessions is genuinely rare. Between them, they watched the K2-18 system for a combined 33 days, deliberately timed to cover at least one full orbit of the planet, since K2-18b circles its star in about 33 days. They scanned an enormous range of radio frequencies from 544 megahertz all the way up to 9.8 gigahertz, a far broader range than most previous searches like this have ever attempted. And then came the hard part. Radio telescopes don't hear alien signal the way it sounds in a movie. They hear everything: cell phones, satellites, radar, Wi-Fi routers, airplanes. Earth is an incredibly noisy planet, and almost every signal a telescope like this picks up comes from us, not from space. So, the team built a filtering system to separate real candidate signals from Earth-based noise. They excluded known contaminated frequency bands. They checked whether each signal's frequency drifted in a way consistent with the physics of a planet orbiting a star. They compared signals detected in the direction of K2-18b against control beams pointed elsewhere in the sky to rule out anything that wasn't actually coming from the right location. From the VLA data alone, they identified over 20 million individual signal detections. After applying every filter, checking every candidate against every control, here's how many held up as a possible genuine techno-signature from another civilization. 0. It's tempting to hear they found nothing and move on, but that's not really what happened here. And it's worth sitting with what a null result like this actually tells us. This search didn't just fail to find aliens. It placed a real scientific upper limit on how powerful a radio transmitter would have to be for it to exist on K2-18b and still go undetected. Any continuously broadcasting transmitter within a certain power range, comparable to the kind of radio technology humans currently use, simply isn't there. Wasn't found. Isn't there, within the limits of what this search could detect. That's a genuinely useful piece of information. It doesn't rule out life on K2-18b. It doesn't even fully rule out a civilization there. Only one broadcasting continuously in this frequency range at this power level during this specific window of time, but it narrows the possibilities in a real, measurable way. And in science, ruling things out is how you eventually find the thing that's actually there. Here's the part that might matter more than the result itself. The tools built for the search are reusable. The filtering framework the team developed, the way they separated real candidates from noise, the way they cross-checked frequency drift against orbital motion, the way they use control beams to rule out Earth-based interference, all of that becomes faster and more sensitive with every future search. This wasn't really a search for one planet. It was a test run for a method, one that future SETI searches pointed at other promising worlds will be able to use and improve on. K2-18b was the first target good enough to justify building this system. It almost certainly won't be the last. So, no, there's no evidence right now of a civilization on K2-18b broadcasting to the stars. But 124 light-years away, there's still a planet that might have a global ocean, an atmosphere that keeps surprising the scientists studying it, and a debate that's nowhere close to settled about what's really happening in that ocean's chemistry. We didn't hear from anyone on K2-18b. That doesn't mean no one's there. It means we just got a lot better at listening. If you want to know the moment that changes, subscribe. This is Space Report.